So one of the first advanced VPC features that we're going to discuss is VPC Peer Gateway. And essentially, VPC Peer Gateway allows a VPC switch to act as the active gateway for packets addressed to the peer's router MAC, or the peer's burned-in address. It keeps forwarding of traffic local to the VPC node and avoids the use of the peer link. This was really introduced to allow for interoperability with features of some NAS and load balancer devices, and certainly would be a best practice and something that would be recommended to be deployed when you deploy VPC day one. The second VPC advanced feature that we'll discuss is VPC Peer Switch. And VPC Peer Switch allows a pair of VPC switches or a VPC cluster to appear as a single STP route in the L2 topology. It simplifies the STP configuration by configuring both VPCs with the same STP priority, and it improves convergence during VPC primary switch failure and recovery. That's really its intended use. As we talk about VPC failure scenarios in a later sublesson, you'll see how there could be reconvergence if the VPC primary, which houses the STP route, would fail. The next VPC advanced feature we'll talk about is VPC ARP synchronization. It needs to be enabled on both VPC devices, and after the peer link comes up, a ARP bulk sync is performed to the peer switch device, and it improves the convergence for all layer 3 flows. And again, we'll do the CLI of these features. They're very simple to configure at the end of this lesson. So the next advanced VPC feature we'll discuss is VPC orphan port suspend. So we discussed VPC orphan ports in an earlier sublesson, and just to rehash that, a VPC orphan port is a non-VPC interface on a switch where there are other ports in the same VLAN that are configured as VPC interfaces. Historically, orphan ports have caused trouble and been problematic, so with some of the most current releases of NXOS, you can actually configure orphan ports to be suspended. And essentially what that will do is during or after a VPC failure, when the VPC secondary would shut down all of its VPCs, in addition to shutting down the VPC interfaces, it will also shut down the orphan ports that are configured to be shut down with the orphan port suspend command. So essentially, to illustrate this, if we were to lose the peer link here in this scenario, traffic that traditionally would have flown over or been routed over the link on the right to the server down here that is using NIC teaming and not VPC, those links after that peer link failure would be shut down. So these orphan ports are now shut down, and traffic can now fail over and is supported over this particular interface. Next, we'll touch on a VPC auto recovery. So just a quick note that reload restore has been superseded by the auto recovery feature. There are two cases of single switch behavior that are addressed by the VPC auto recovery feature. The first is recovery of the second VPC peer after a dual failure. So the first occurrence would be if the peer link goes down, the VPC peer shuts down all of its VPC member ports. Then if the VPC primary goes down, VPC secondary no longer receives the keep alive messages on the VPC keep alive link. What auto recovery would allow is after 3 consecutive keep alive timeouts, the VPC secondary peer changes its role and brings up VPC. So essentially, in this scenario, it's allowing the VPC secondary to come back up if the primary fails and doesn't restore. The second use case for VPC auto recovery is the restart of a single VPC peer. When a VPC peer is missing, by default, VPC doesn't allow any VPC member port to either flap or for a new one to come up for that existing VPC after a reload. So what auto recovery allows is it monitors the peer device, and if the VPC is not available, it allows the new ports to be brought up even if the peer is missing. So now I just want to cover some STP and VPC interoperability and best practices. So we talked a lot about how VPC handles loop avoidance and works differently than classic spanning tree would have. But it's important when we look at spanning tree to continue to leave spanning tree enabled, right? So spanning tree can serve as sort of a fail-safe to VPC. So we don't want to disable spanning tree even in a VPC environment where you're using VPC. You still want to use rapid PVST or MST. And then certainly from an STP point of view, it's also very important to limit the size and scope of changes that are occurring in the layer 2 domain. So you certainly want to configure port fast or port type edge or edge trunk on host-facing interfaces where applicable in your network. So now let's jump into some of the CLI for some of the advanced features we discussed. So let's take a moment to look at and configure a couple of the advanced features that we discussed. The first is peer gateway. So I'm going to go into configuration mode, and all three of the features that I'm going to talk about now are configured under the VPC domain. So I'm going to go back into my VPC domain, which is VPC domain 10. The first is peer gateway, right? So to enable peer gateway, we simply issue the command peer gateway, and this would be enabled on both of our Nexus switches. If we wanted to enable peer switch, we would issue the command peer switch. Now with peer switch, if you have non-VPC attached devices, you may need to alter what's called spanning tree pseudo information so that the peer switch is backwards compatible with non-VPC devices. That's outside the scope of this particular lesson. And then last but not least is auto recovery. Again, this feature would be enabled on both of our VPC peers, and the command to do that is auto recovery. You can also adjust the auto recovery timer if necessary. The default is 240 seconds. Now we'll look at orphan port suspend. So I have a device plugged into interface Ethernet 121 on my 7K. Now this 7K is configured as part of VPC domain 10 with N7K2. And I also have that device plugged into Ethernet 121 of N7K2. Unfortunately, the device isn't able to do a port channeler VPC, so I have to rely on NIC teaming. So I want to configure it as an orphan port, and I want that orphan port to be suspended in case there's a VPC failure, so traffic can still fail over to it after a switch failure. So again, I'm going to go into config T mode, and with orphan ports, you actually configure them on an interface by interface basis. So I'm going to go into interface Ethernet 121 again, and I'm going to say VPC orphan port suspend. That command will suspend the orphan port in the event of a VPC failure.